Okay, we're going to address solving systems of linear inequalities. So how are systems of linear inequality similar to just solving for one linear inequality? Well, they're similar in that we're still going to use the idea of when we have less than and greater than signs, we're going to keep using dotted lines. When they're less than or equal to or greater than or equal to, we're going to use solid lines. We're also going to include shading, whether it's greater than or less than. And what we're going to do though now is with systems, we're just going to add more lines. I'm only going to be addressing 2 lines in this particular lecture. Otherwise, in most Algebra 2 classes, you'll have 2 or 3 lines or more, 3, 4, 5, and it's basically the same principle. So let's kind of remind ourselves here, and let's take a look. So we know a line represents all the solutions to an equation. And then because we're using inequalities, we're going to be involved with shading. So here I've shaded above the line because I have a greater than or equal to statement because of the solid line. Now, with the system, what we're going to do is we're going to have a combination, or what we're looking for, a common solution to a set of lines or multiple lines. In our case, again, we're only going to be using 2 lines. And what we're going to do is where they cross, where they are common, we're going to darken that area in, and this is the area of the common solution. So any point that is in this area here will be a solution to this system. Solutions out here are not solutions to the system. So for example, this point here, which happens to be 3, 3, this point is a solution to this particular linear inequality, but not the system. A point over here, for example, -5, +1, that is also a solution to this linear inequality, but not a solution to the system. 0, 0 is not a solution to either line or the system. So we're looking only for points that are within this realm. Okay, now we'll take a look at finding and how do we know if something's a solution to the system without graphing. So all we have to do is remember that this is the x and this is the y, and we plug it into the inequalities to find out if it is true or not. So let's take this first one, and this will be -3 is less than or equal to -3 times -1 plus 1. If we simplify it, we'll end up with -3 is less than or equal to 4, and we know that that is true. So far we know it's in the shaded region of at least one of the inequalities. We'll take a look at it in the second one here, y is less than 2x plus 2, and we'll substitute in -3 is less than 2 times -1 plus 2. And we'll again begin to simplify that down, and once we do, we can find out if it's true or not. So -3 is less than 0. We know that also to be true. So this point happens to be in both regions. So is this a solution to the system? Yes, it is. Let's do it one more time. Let's take a look at the point -1, 5, and if it's a solution to the system. Let's take the first one and say 5 is less than -2 times -1 minus 1. Well, when we go to simplify this, we find out that 5 is less than 1. We know that this is not true, that this is false. Well, because it's not in this section at all, we can stop right here and say, no, it's not a solution to the system, because it must be a solution for both of them in order for us to continue. All right, let's take a look at some graphing of some inequalities. And we'll take a look at this first one. They're already in slope-intercept form, which makes things easier for us. When we look at that top one there, y is greater than 4x minus 1, we know that the slope is equal to 4, which rise over 1 will put it over 1, and the y-intercept is -1. So let's begin at -1, and we'll have a slope of +4 over 1, so we'll go up 4, 1, 2, 3, 4, and over 1. We're going to put a line on here, and we're going to make it a dotted line. And our dotted line, let's see if I can get it to be a certain color here. Help us out. Good. We'll take a blue dotted line here and we'll put it through it. Now we need to do some shading. So since it's greater than, we want numbers greater than -1, we're going to be shading on this left side or upper side of this particular one. Now let's take a look at this second inequality. Y is less than -2x plus 3. We know the slope is -2, and that would be over 1, and that the intercept is 3. So again, we start at 3. We would go down 2 into the right one, and then we would get ourselves a line. And again, this one's dotted as well because there is no equal sign. And then we are going to look for this again, less than. So less than 3 would put us over on this side of the line, and we want to go all the way across. And we can see the common area where it's crisscrossing in here, right? So this would be the common area where these are our boundaries. We'll do it one more time, but we won't make it as easy. We'll put it in standard form and then have to convert it to slope-intercept form. So let's first take this first inequality, x plus y is less than -1, and let's convert it to slope-intercept form. So let's get the x off the left side and to the right. So that leaves us with y is less than -x minus 1. Here we have a slope of -1/1, and our y-intercept is also -1. So let's go to our graph, put in -1, and then we'd go down 1 and to the right 1. Now again, this one happens to be a dotted line, so let me get a dotted blue line here. And let's put that dotted blue line in. And make sure that because we're doing inequalities, you really want to extend your lines as far as you can, because you never know when that shaded region is going to show up at. And because it's less than, we're going to shade to the left or underneath the line itself. Okay, now we'll take a look at the second one here. And this one here is 3x minus y is greater than 4. And again, we're going to work on getting that y by itself, so we're going to subtract 3x from both sides. Gets us -y is greater than -3x plus 4. We need to divide everything by -1. And when we do that, that changes the inequality sign. So then we have y is less than positive 3x minus 4. So the information we get from here is that our slope of this line will be 3/1, and our y-intercept will be -4. So if we go to -4 and then do our slope, which is 3/1, so 1, 2, 3, and over 1. And then we're going to draw ourselves a line and connect that. Connect our points. And then we're going to do our shading. So we want less than. So what we want to do is shade below the line all the way across to show its solutions. And then we see what the common solution is, this little TP area here. Okay? So this would be the common area or the common solution. Well, let's try one backwards. Let's try taking a look at a system of inequalities and writing down what the system actually is by looking at the graph. So let's take a look at this line, this dotted line here, and we'll do this one first. And we know that because it touches the x-axis and the y-axis, that the equation has a y and an x. Excuse me, the inequality has a y and an x. We see that the y-intercept is at -2, so we're going to subtract 2 over here because that'll represent the y-intercept. We need a slope. So we see it's +3 over +2. So that will be our slope there, 3/2. And because it is shaded above the line, it would be a greater than sign. And because it's dotted, no equal sign. So we're good with that one. Let's take a look at this solid line going the other direction. And again, we see it touching the x and the y axis. So we know it has a y and an x involved. We see that it's crossing right here at -6. So we're going to put a -6 in that intercept spot. And we're going to find ourselves a couple of points here to find slope. We can see it's going down 1, which would be -1, and to the right 1. So our slope for this line would be -1/1, which is just -1. Now I could put a -1 there, or I could just put a negative sign. That would also mean -1. So I'm going to leave it that way because it looks cleaner. We see that it's shaded below the line, so we know that it's going to be less than. But because the line is solid, we're going to add an equal sign to it as well. I'm going to leave you with a thought. Here's this website. It's a great interactive website where you can load in some inequalities and see how they graph out. You can practice by loading them in and maybe trying to figure out what we just did in the last example. You could do that in there as well.